All right. 10:01 a.m. Might as well get going. Good morning. Victoria, please let me know if you can hear me, see me, if anything's going on. Could I get a volunteer or two to monitor the Victoria Slack channel? Is anyone in the Victoria Slack channel? Perfect. Awesome. All right. How's week one going? This is fantastic. Lots of energy. They haven't let me do week one lectures. They haven't let me at the new students yet. So this is unique for me. This is like your formative time. So I can really screw you. I mean, make you better than you already are. So today's topic is callbacks. But I should probably introduce myself, as this is our first real time together. I helped some of you on Tuesday. I remember that. I am a part-time lecturer and part-time mentor with Lighthouse Labs. I am a Lighthouse Labs alumnus. That's the singular, right? Alumnus. I don't have a computer science background. I don't have a bachelor's degree. I don't have a master's degree. I'm a university dropout. I spent 20 years in the logistics industry. And I kind of have the gray in my beard to show for it. Yes, sir. Yes. Yeah, it'll be September 16th, but it will be Web FT Vic. So Web Full-Time Vic, September 16th. Oh, perfect. Thank you, Caitlin. Sounds good. Awesome. Victoria, are you there? Awesome. Okay. Where were we? Okay, yes. So not too long ago, I was exactly where you are. Okay, so I was doing something completely different, working in a warehouse, driving a forklift, operating a pallet jack, and then I decided maybe I should do something different with my life. So I made a sharp right turn. I came to Lighthouse Labs. I graduated, got a job, and the rest is kind of history. So if you have any questions about that, if that kind of resonates with you, that going from a completely different career to transitioning into tech, then feel free to hit me up on Slack or in person if you have any questions. Yes?
How many years have you been since your cohort?
I was in 2018. So there you go. Cool. Any other questions about that? I don't usually like to talk about myself. I'd much rather talk about that. Cool. Awesome. So sound is good in Victoria. Fantastic. Okay, so today we are going to talk about, how's the font size in the back? Can you read that? Perfect. Okay. If you can't see anything, if something's too small, just yell out. Just say, hey, can you make that bigger? The purpose is I'm not up here just talking into the void. I'm talking to you. And if you can't see what I'm writing, then let me know. Okay. Also, I love to ask questions during lectures. Some cohorts are more responsive than others. They're never trick questions. I'm never going to ask you a trick question. I'm legitimately going to say, what does HTTP stand for? What does HTML stand for? Does anyone want to take a guess? That kind of thing. So there's no wrong answer. The other reason why I ask questions is even if you don't give an audio answer, I want to give you a second to think about it. One of the things as programmers is we always want to have kind of an assumption about what's going to happen. We'll get caught by surprise, but we want to have, sometimes, but we want to have a guess. Before we press enter, what is this code going to do? What's the output going to be? Because if we don't have an idea of where we're going to get to, how are we going to correct ourselves when we go astray, right? So before you run your code, always have an assumption, just even a guess about what's going to happen, what error you're going to see, what's going to print to the console, stuff like that. So I ask those questions as well, even if you don't want to raise your hand and answer, but take a second, think about it. Think, do I know what HTML stands for? Do I know, the answer to the question? But I will ask a lot of them. I also like to start with to-dos to keep myself on track and to have some kind of accountability at the end. They're hopefully ordered in the way that we're going to go through them in this talk, but we'll see. This is more of like a conversation that we're going to have, because this topic today is a big one. People can struggle with it, sometimes for weeks, not really understanding what a callback is. And I'm hoping that by noon today, everybody will have at least a good idea of what a callback is. Okay? So let's see. What did you cover yesterday? What were the big topics of yesterday? Objects. Fantastic. Personally, I love objects. I feel that that is the moment where someone goes from being not a programmer to being a programmer. Because if you can wrap your mind around how an object works and properties and embedded methods and stuff like that, then, you know, everything else is simple after that. So that's kind of my barrier is like, do you know how objects? Okay, you're a programmer. Exactly. So welcome to web development. Okay, so in a nutshell, we might as well get this right out of the way. There's various different ways to teach about callbacks. I want to try this straightforward approach. What is a callback? Now, in a nutshell, let's give myself some space here. A callback is a function that gets passed to another function to be executed by that function. Yes, that's as convoluted as I can make that. If you understand that, then you can stop paying attention until noon. That's all it is. A callback is a function that we pass to another function that function then executes. That's it. So hopefully by noon, if we reread that, you'll be able to say, ah, that's what he was getting at. Cool. Okay. So first things first. I am in, tiny town. Let's get a little better. There we go. Okay. So I am in an reasonably empty directory. Anything for Victoria? No. Good so far. I am in a reasonably empty directory. The only thing I have is this readme file that we've been working on. So I want to commit this to Git so that I can share these notes with you afterwards. So what's the first thing that I need to do? You talked about this with Travis on Tuesday. What do I have to do to set this up so that I can commit my code to Git? Git init. Perfect. So now I have an empty Git repository initialized, and it's been put into the .git folder. So if I run ls-l A, we see that we now have a folder. If you're not aware, you can give arguments to ls to list other things, like just the default ls. Let's clear my screen. Just the default ls just lists your files out in order, and it doesn't show any of the hidden files. ls-l gives you a little more information. That's the one that I prefer. You get the file name, you get the last updated date, you get the number of bytes in the file, you get who it belongs to, who wrote it. I don't know who this guy is. And if you pass A, you get to see all the hidden files that are in the directory. Yes?
What happens with lowercase a?
Lowercase a will show you, let's do these side by side so you can see, ls-A, ls-lowercase a. What's the difference between those two? It's actually showing us 2 extra files that were excluded from this search. And these are actually symbolic links. These are what enables you to be able to go like, that's exactly what that is. You want to change directory and you want to go up, or you want to look inside the current directory. So passing A instead as a flag gets rid of those because those aren't really useful to us. But any other hidden files, those could be useful to us. Does that make sense? Cool. Okay, so we now have our Git repository. I can run git status to see what's going on. I have one untracked file, brand new file. So what do I have to do to add this so that Git knows to keep track of it? Git add, yeah. And then what can I pass as an argument to git add? I could add the name of the file, or I could just use my personal favorite, which is the period, which just adds everything that's currently not tracked. So there we go, git add, And then if I run git status again, we see that we have a new file that's been created, our readme.md. What's the next step after I've added it? And I've run my git status again to make sure that I'm only going to commit what I want to commit. Oh, I gave it away, didn't I? See, I said there'd be no trick questions. What do I have to do now? Git commit. That's correct. And git commit takes an argument, right? You can do -m and then pass a string to it so that you just name your commit. Here, I'll tell you what I'll do. Oh, by the way, if you've typed along, if you're all the way over here and you're like, ah, man, what do I don't want to have to do this, just hit Control-C and you'll just kill that line of code. So let's clear this, run our git status again. By the way, I have all of these aliased. So if I ever type anything that looks bizarre, just let me know because it's I've forgotten. Like I alias everything, so I have git st and stuff like that. If I do that, just remind me to actually type out the real word so that you can see it. Okay, and I completely defeated the purpose of clearing it. Perfect. Okay, so we are at this point. What's next? Starts with a C. Git commit. Perfect. -m. And since this is the first one, I'm just going to call it initial commit. Perfect. Now if I run git status again, I see that I'm on branch master and I have nothing to commit. Okay, cool. So we're ready to get going. So I'm going to touch a file. I'm just going to call it examples.js. And we'll jump back over here and we'll get into some examples. Okay, so we are familiar with, at this point, storing values in variables, right? So if I had said something like const name equals Andy, you understand what's happening, right? We're storing the string in a name, right? We can do that with all the other data types. We'll say we got my age. Oh, shouldn't have posted that on the internet. What else can we do? What other data types do we have available to us? We've got a string. We've got an integer or a number. What else do we have? Boolean. Const, what do I have? Awake. Perfect. There we go. We have a Boolean value. So we can do things with these, right? We could pass them to functions. We could pass them around. We could concatenate them into other strings. I could say like const greeting equals. Do you prefer template literals or the concatenation operator? Or do you prefer to do this with this, or do you prefer to do that kind of thing? The first one? Okay, perfect. Template literals. So I could be like, hello, name. And I can pass these around, right? What is going to happen here? What is that going to become? Hello, hi. We did this already like 10 minutes ago. All right, sorry, yeah. And then we can console log that, right? This is a function that we can pass things to, right? Is that still big enough for everybody? There we go, console log. So we could pass something like our greeting to that, right? And what do we expect to see if I run this code? The exact same thing, right? We expect it to console log hello Andy, right? Let's find out what happens. Great. We're off to a good start. If you didn't notice what I did there, you can use tab to autocomplete so that you don't have to type out the rest of the file name. And if you had, let's touch examples 2. If you have, oh, that's actually too close. Let's call that, we need another word that starts with E. Each is the only thing that comes to mind. So now we have 2 files. We have examples and each. Oh, that went wrong. Okay, let's do this again. So I have 2 files. Let's say I can't remember which one did I want to run. I know it started with an E. Let's say I've got hundreds of files in this directory. If you press tab, tab, it will actually do a little ls for you so that you can just continue writing. And then all you have to do is just make it unique, and it will autocomplete. Okay? These are some bash helper things, because I hate typing out the entire file name every time. This is like 8 characters. That's way too many to type. Cool. Okay. Any questions about this? This is like pre-boot camp prep course kind of stuff. We're good to go here? Awesome. So let's say that we wanted to encapsulate this kind of thing to run it again and again. What could we use to do that? If we want to encapsulate a block of code to run again and again at some point in the future to get the same kind of behavior. Create a function. Perfect. So what's one of the ways that we can create a function? We can just declare it. We can just say function. Let's call it, let's get rid of this. And we'll call it greeting. Okay? And it's going to take an argument. And then inside of here, we're going to console log hello name. Does this tracks for everybody? This is fine. How would I invoke this function? What happens if I run this file right now? What's going to happen? Absolutely nothing. Yes, and this is a big gotcha that you can get into, is you create a function, and then you run the file, and absolutely nothing happens. What do we need to do to make something happen in this file? We could return, but we need to call the function. That's right. So we need to at least do something like this, right? We call a function, or invoke a function, if you want to use the computer sciencey term, by open and closing round brackets afterwards, right? Parens. And then this particular one takes an argument, right? So we need to pass something into here. Let's try a string, see what happens. And this font size. Hello, Terry. There we go. Is anyone surprised by that behavior? That kind of happened exactly like we thought. Well, what happens if we did something like, we're going to pass like an integer? Well, it should be fine with that. Hello, 37. Hello, Terry. Totally fine with that. It took whatever argument we passed in, and it put it inside this template literal, and then it passed it to this function, right? We could have done what we did before, which is store it in a variable. And then do that. Will that result in the same, exactly the same thing to the console? Yeah. And just to test it, there we go. Hello 37, hello Terry, right? Nothing has changed about this. Now do you have any thoughts on this? We have name as an argument for greeting, but we also have a name in the global scope. So what would happen if I did this? What will happen if our function no longer takes an argument? A name will become Andy. That's right. It's going to, and just so that we check that. That's right. We're invoking it down here. Here, I'll just put something on this line so that we can scroll around. There we go. Oh, that's going to cause the file to error out. There we go. Yes. So what's going to happen here? Is it, who thinks error? Who thinks this is going to throw up all over the console? Cool, cool. And who thinks it's going to output hello Andy twice? Okay, so we all have a guess. Was that shocking to anybody? Cool, awesome. That's great. We always want to challenge, because if your assumptions are challenged, then you create different assumptions in the future based on what you've got. All we can do is we sum up all of our current knowledge, and then we make a guess about something. And if something challenges that, then we just go, oh, okay, I guess it's different than I thought it was, and we just change our perspective. To be a developer, we are constantly learning, all the time. Every single day, we are learning something new. Something new is coming up. When I get together with the mentors, they're always excited to say, oh, look at this new language, this new framework. Look at what I learned. Look at this neat new trick that I didn't realize JavaScript could do. So don't be afraid to learn new things. Don't be afraid to be wrong, okay? Just be flexible. You just change your assumptions. KV likes to say, get comfortable with being uncomfortable. And once you come to terms with that, then you actually take comfort in being uncomfortable, being in a position where you don't know everything. That's one of the biggest things that I noticed coming from outside of the tech industry is in a lot of jobs, a lot of careers, you can get to a very professional level where you know pretty much everything there is to know about your chosen field, right? Does that resonate with anybody? So you can gain this skill set, whereas the tech industry is massive. It's absolutely massive. It's not possible for one person to learn anything, to learn everything. And it's also constantly evolving. 4 years ago, I would be teaching you Ruby right now, not JavaScript. But the ecosystem, because of Node, has pushed all of that Rails and Ruby out of the way. And now the dominant player in the industry is Node, because we can have JavaScript on the back end and the front end. But 5 years from now, who knows? Maybe this will be a closure course. Maybe they will be teaching Rust. Maybe we'll be teaching PHP and we'll have like an internet renaissance. Who knows? But you're constantly learning and you're always going to, so just be comfortable with that. That you're going to learn new things and you're never going to know everything, and it's totally fine to say, I don't know what that is. Can you explain that to me? Okay, yes? Yeah, absolutely. Yeah, sorry. Okay, so a couple of things are happening here. One, I'm making reference to this variable name. So JavaScript looks inside of this function and it says, is there any variable called name inside of this function? Well, it can't find anything. Well, were there any parameters that were passed in called name? Doesn't find anything. So it moves outside of its, what we call scope, but you don't really have to be concerned about that right now. And it will move out of there and it will explore the rest of the file. And it will say, great, well, what if I move outside and I see if there's anything outside that has a name? So then it goes up and it says, yes, I found one. Fantastic. So when you invoke this function, when this function is invoked, it just goes, okay, I know where to find name. It's up here. And it puts that into here and everything's fine. Now this, why this works is because JavaScript is extremely flexible. JavaScript doesn't really have any problems with you passing more arguments than a function needs, or less arguments than a function needs, or just the right amount of arguments that a function wants. JavaScript won't throw an error over this. Other programming languages will. But JavaScript just goes, okay, yeah, we were expecting none, you passed 4. Okay, we're not going to do anything with that. We could even set those up here. Name, awake, what would be null? Having, oh, is bored. There we go. That would be null. And now we're back to 37 and Terry, right? Because we're actually accepting something for this argument. We can also just invoke it with nothing, right? We could also invoke it with nothing when it accepts an argument. What is this going to print out? Good guess? Just hello? That's another good guess? Everybody have a guess in their head? Okay. Clear the console. I should have like drum roll music here. Hello, undefined. Why do you think that happened? That's right. We didn't define it, but we did do something to it. We declared it. when you put something in as an argument, behind the scenes what's actually happening is, it's actually probably using let. This is what's happening. It's actually creating a variable for you with this, whatever you've named it. And name is a poor choice. Let's move to, actually let's just leave it at name for right now. So it's actually declaring a local variable called name right here. So let's comment this out for a quick second. Let's do a little more experimentation. Okay, so I'm going to say is this valid JavaScript? Yes. And that might have been a bit of a trick question because you really have to go out of your way to do invalid JavaScript. JavaScript is very, very flexible. Okay, so what will this first console log output? Undefined. That's right. And then we actually set it up, and then we console log. All right, so when we run this, we see undefined, and then Francis, right? Okay, because what's actually happening here, if we do this again, and we just take Francis and the equal sign up to here, and get rid of one of these console logs. This, saying let name equals, is actually a shorthand for what we were just doing. Let name, and then name equals something. These are two separate, Francis, there we go. These are two separate things. Let's just call this name 2. But these are two separate actions that are happening right here. Here, we are declaring a variable, and here we are defining the variable. And so the initial status of every single variable that gets declared is undefined. Exactly, because it hasn't yet been defined. So the fact that up here, if we don't pass any argument to this, this variable is still created, but it's sitting in this state here. We didn't pass any arguments to it, so we didn't actually do the assignment. So that's why it outputs hello undefined. And we don't get an error or anything. Victoria, keeping up? Any questions or anything? Does that make sense about why this now works without any kind of arguments, without any kind of complaints from JavaScript? We should be back to hello undefined. Okay, but I want you to, at this point, it would be nice if we could separate logically, because we do this a lot as programmers. We deal with abstraction. That's the whole thing that we do as programmers. We bundle up complexity inside of little packages to be used by ourselves or other developers at a later time to build more and more complexity. So we are encapsulating this logic here. We know that inside of our function, the implementation is that we create a string where we interpolate the name, whatever gets passed in, into this, and then we output it to the console. That's what this function is doing. Okay? But the consumers of our function, ourselves or other devs, they don't need to care about this implementation. They don't need to care about what's going on in here, right? They just say, well, I know that I call greeting and I pass it, presumably a string. At this point, it's any variable, any kind of value, and something happens, okay? So to that end, do I need to call this name? Let's say I want to pass in Andy up here. Does this need to be called name? No, absolutely not. You can call this whatever you want. This is your playground inside of this function. You are the developer who is coming up with this code, this abstraction layer. We can call this whatever we want. What's a crazy name that we might call a variable? Doesn't really matter. Let's just call it something like text. Is this still going to console log hello Andy? Yes. Yeah, absolutely. Wow. There we go. Clear? Hello Andy. We're back to that. So you can name this whatever you want. What happens inside of this function is your area. It's not dictated by the people who call the function. We can call it with anything. We could put in a string here, the string name. We could pass in any kind of variables we want. You're in control of naming what comes into your function. It's just like if you were inside here and you had another var equals something else, right? So I want to make that clear that you don't need to name these things the same in order for this to work. Okay? Am I losing anybody? We're still okay? Cool. Okay. So now we've got our greeting function. Let's come up with a function that does something else. For simplicity, let's go with some kind of like string manipulation or number manipulation. Does anybody have a short little function that we could do something? Cool. We're going to write a function that doubles a number and then writes it to the console. That's going to be fun, right? That's why you came to Web Dev Bootcamp to see that. Okay, so this is one way of declaring a function. What's another way of declaring a function? Using a variable, exactly. So we're going to call this one const double it equals function. Presumably, we're going to take in some number. And then we're going to operate on that number. So let's call this const double equals num times 2. And then we'll console log double. Okay? So how do I invoke this function? Because we didn't declare it in the same way. This one we could invoke it with just calling greeting and then putting the round parens after it and then passing it an argument or not as we decided. How do we call this one? How do we invoke this function? How do we invoke, rather, this function? Yes? Yes, exactly. We can just do this. And what is this going to do for us? Let me just comment out the greeting so we don't see hello Andy all the time. OK, so let me unminimize that. By the way, I love this feature of VS Code. Sublime and the Atom and stuff have it as well. But just being able to collapse your code into logical code blocks. When you have a file that's filled with functions, just collapsing them down, and then you can see the name of the function and the arguments that it takes. And it makes it a lot easier to skim through a big file, I find. OK, so we have this function called doublet that takes in a number and then multiplies it by 2, and then console logs double. So what happens if I just invoke it with nothing? Cool. Let's find out. Well, this one we're going to invoke with nothing, and then this one we're going to invoke by passing in the number 2. Or let's do something more interesting to double 5. Yes. Yes. We're going to get into double digits here. OK. Ooh, we got a special value back. Can everybody see that? We got that nan. And not the kind that you can eat. This is a different nan. What does this nan stand for? Not a number. Exactly. So we tried to perform math on something that was not a number. So the value that was stored in here became, and then we just console logged nan. If you try to perform an operation on a value that doesn't support that operation, then you'll get nan. If you try to do some kind of math on something that's not a number, we'll get not a number as a result. And then, of course, we got our double digits here, 10, which shouldn't surprise anybody. Okay, so, but we've reached an interesting place here. We can see everything on the screen there. Okay. What is the difference, or what are the similarities between this line of code, or lines of code, and this line of code? Sorry? Between double it and like awake equals true. Yes, we have defined a function and stored it in a variable, right? And that's exactly what we're doing up here. So if we were going to collect these together, we would call these something like values, right? We're going to store a value in a variable. Nima likes to talk about variables as like buckets that you store things in. So we have our value here. So by default, let's say you didn't know anything about JavaScript or anything about programming, but you saw, well, const name equals some value, const age equals some value, const doublet equals some value, presumably, right? Does that make sense? Since we're able to actually store it in there, so by extrapolating that out, we can realize that JavaScript actually stores everything as a value. Everything that happens, even something like this, behind the scenes is being stored as a value. Okay, so can I do something like this? Const is that valid? Yeah. So if awake was true here, what is the value of awake 2 going to be? True. Exactly. So we can pass these things around, right? We can use string interpolation to concatenate things together. We can play with these different values that are passed, these different values that we have. So what would happen? Let's return this instead. We're going to return the doubled number. Okay? So I'm going to just console log, double it with 2. And then I'm going to do something. Oh, let's do that just to make sure that everything's working. So all I'm doing now is just returning that doubled value. So what is this going to? Oh, we need 7. There we go. We're going to learn some math today. Whatever 7 plus 7 is. Should be no surprise that we get 14, right? Does that track for everybody? We're just doing the exact same thing, except we're wrapping it inside of a console log. So what is the order of operations that's happening here? Is the console log being invoked first? Or is doublet being invoked first? Doublet. That's exactly right. We work from the inside out. Same thing if you remember math, you could do like 8 plus 9 times 2, right? And this gives you the order of operations. We put brackets around it, right? So we say, because that is certainly different from that, right? If we remember, what is it? BEDMAS? Do they still teach BEDMAS? Or BEMDAS? Brackets, exponents, multiplication, division. Anyway, stop me if I go on too many tangents. Okay, so, but we can do that, right? So we see that this will be invoked first. And whatever the return value is from this is going to be passed to the console log function. Okay, so what if I do that? If I can console log awake and we get back true, if I can say the variable's name and we get its value, what happens if I say this variable's name? Let's find out. It tells us it's a function called doublet. But we're not getting any output to the... What happened to my 2 times 7 that printed out before? Why am I just seeing this? Yes? Do you need to pass it an argument? In order to, because here, if we just... You're not invoking it. Exactly. I'm not invoking it. I'm just saying its name. And so when you say its name, you actually get back the value. Just like if we said, I think everyone will agree that if I said awake anywhere in my code or name anywhere in my code, I would just get back the value from that, right? So the same exact thing is true with functions. If you say its name, you get back its value. If you invoke it, you get back its returned value. Okay? So if we're okay with that, are we okay with that? What do I want to double? Triple digits this time. Maybe. Maybe. That was a presumption that I was making about what this code is going to do. Any presumptions about what is going to be console logged from this? Yes? Okay. Possibly an error. We might see an error. Any other guesses what we'll see? Maybe it'll run the doublet function. Maybe it will. Maybe we could console log another func as well and just see what that value is. We'll just say its name, but we won't invoke it. Okay, here we go. Moment of truth. Function, doublet. Well, that's... I console logged another func. And I got out function doublet. And then I got our first triple digit number, 198. Okay. Why did this give us 198? That's exactly right. That's it. If this is just a value, we can just pass it around like any other value in JavaScript. If that's valid, if I can spell it correctly, if that's valid, then this is certainly valid. Absolutely. We can do this as many times as we want. We can pass this thing around as a value. Okay? And then we can, because it's a function, we can execute it. We can console log it. We could even pass it to a third function equals another function. Let's just console log this one to see what it looks like. Function doublet. So it knows, JavaScript knows, that we stored inside of doublet, we stored a value, which was a function. Then inside of another function, or another func, we stored whatever the value is, right? Because how do we know the value of awake 2? How do we know what that's going to show us? Because we already know the other value. This isn't like a guess. We know that this is going to be true. And we know that when we say a variable's name, we get back its value, right? It's not going to store like this string awake inside of awake 2 or something like that. It's going to say, what is inside of this? Oh, it's true. Okay, perfect. Store that inside of awake 2. And we know that awake 2 is true, right? And if we change this to false, that would be an odd lecture, but it would be false inside of there, right? So the same exact thing is true down here. We say its name, and that gives us back its value. Okay? And then we're able to set it into another variable. Yes? That's correct. That's actually correct. Since this is a primitive value, so we have some primitives in JavaScript, right? We have strings, we have Booleans, we've got numbers, integer types, floating, whatever, right? And what does a primitive mean in terms of JavaScript, in terms of programming? What is a primitive value? It is a small piece of data. I don't know enough about the compiler to actually know if it is a building block of the language. Presumably it might be. But it's not called primitive necessarily for that reason. It's called primitive because it's a very simple data type. So simple, in fact, that we just stick it right into memory. If we could look inside the computer's memory, there would literally be 6 adjacent slots, or 4 adjacent slots. Don't even know how many letters are in my name. 4 adjacent slots that literally the value A, N, D, and Y are stored in my computer's memory. Literally those values in a row, because this is a primitive data type. Literally the binary interpretation of 38 is being stored in my computer's memory. But functions are a different animal, aren't they? They're not a simple data type. They're not a primitive, right? So as you suggested, we actually store what's stored in doublet is actually the reference to this function. Because complicated data structures can grow, they can shrink, they can be of indeterminate size. Imagine you have an object and you start adding multiple various keys to it, or you have an array and you're pushing values into it. If you had that set in memory, presumably you have this area that's set aside. If we think about our memory as just a giant box, we have this area set aside for A, N, D, and Y. And name knows where that starts, and it knows where it terminates. It says, look for in between this memory slot, go this many, and you'll get back literally the characters A, N, D, and Y. Age says, go to this memory location. This number is this big. Retrieve it for me. But what if you have an array? So you've initialized an array. We're going to call it R. And we'll put in like apples and oranges. Great. That array has 2 elements in it, and they're both strings. They're both primitives. So you might think that, well, it's going to just set aside in memory. It's going to say, OK, we have these 2 boxes side by side, just like any other primitive. And then we move on. But what happens if we do this? Let's say it's walking through our computer's memory and assigning these things. It's putting these things into RAM. So it makes a box for false. And right next to that, it makes a box to hold an array of apples and oranges. And then next to that, it makes a box to hold false again. So if we're thinking about, how are we doing for time? 10:49. If we're thinking about our memory in our computer, we have false, apples, oranges, false, right? But what if I do, what if I did that? That's perfectly valid JavaScript, right? If I console log R, make sure we don't have any other console logs going on. OK, I should see apples, oranges, and lemons, right? Our array has grown bigger. But if our mental model of false, apples, oranges, false, where did lemons fit into this? Where would the computer put that into memory if we just went with the way we store primitives, which is we literally just put it right into memory? So the computer knows, well, JavaScript knows, because some programming languages do say that when you create an array, you have to dictate how big this array is going to be. And you can change it later, but you can't dynamically resize it the way that we do in JavaScript. Because I could also then go pop, right? I could pop lemons back off of there. And then when we console log it, we're back to apples and oranges. We can dynamically change the size of arrays, right? So complicated data structures like this can't just be literally put into memory. Instead, we have a reference to a spot in memory, and that reference, that spot in memory, knows where all the other stuff is stored and can retrieve it for us. But we don't actually have, and that's also why, you notice what else we're doing here? We cannot do this, can we? Let me just move this down for a second so that we... Const awake equals false, or awake equals true. Assignment to a constant variable. But I said const array, right? And then we were able to add elements to it and remove elements from it, which is something that we're not able to do here, because this value is literally put into memory, whereas this one, it's also put into memory, but put in a different way. This is just a reference. So as long as we don't do something like this, we are perfectly fine. Does that make sense? This is going to complain as well for us. Wait, assignment to a constant variable. Do you see what's happening here? We declared this as a constant. We set it up as an array. We can add things to it. We can pop things off of it. That's totally fine. But if we try to put another array into that variable, that's when we go, no, that's not right. Okay? So complicated data structures, anything more than a primitive, is being stored as a reference. When we say the variable's name, we actually just have a reference to that variable, and we can pass that around. And that's why we are able to pass this around and execute it. So we're just passing a reference. That was a long way to go from that question that you had. Cool. Did I confuse anybody with that? We are at 10:53. Why don't we let that sink in? We'll take a 10 to 15 minute break, and then we'll do some more fun stuff, and we'll get back to working our way through our to-dos. Cool. All right. 6 after. Everybody back for the most part? Cool. All right. To keep on track, because we only have 54 more minutes, let's run through our to-dos. Can everyone agree that functions in JavaScript are just values? Is that pretty clear by now? We can pass them around, we can store them in variables, we can pass them between variables, stuff like that, right? Functions are just values in JavaScript. Function calling versus passing, we haven't really touched on yet. Callback functions. We're still working on it. Let's revisit our description here. Let's throw something down there. A callback is a function that gets passed to another function to be executed by that function. Are we any closer to explaining that statement? Kind of? Kind of, not really? Okay. We have 53 minutes left to make that make sense. Okay, so we've done various different things. So one thing I'm going to quickly do is I'm going to run git status. I see that we have modified the README, and we've created 2 new files, but this one was the one that I created to just show you an example of the tab autocomplete feature. So how do I get rid of a file? Yes, RM. That's right. And tab autocomplete, and it should be gone. Let's run git status again. Okay, so now we just have the modified README file. And then we have a brand new file that's in our untracked files. Okay, so we're going to git add everything. I always run git status again to make sure that I haven't accidentally included something that I shouldn't have. If you need to, and Travis probably covered this, you can just do git reset. And then when you run git status again, you'll see that everything is not staged for commit anymore. Okay, git add, git commit -m, first half of lecture. There we go. Now if I run git status on branch master, nothing to commit. Awesome. Okay, let's get back to callbacks. Okay, so we already established that. Let me touch a new file. Call it callbacks.js. Okay, here we go. So we have already established, we took the first hour to establish that functions are just like any other value in JavaScript. We can store them in variables, we can pass them around, we can reassign them, and then we can invoke them should we want to. So they have a little bit more functionality than a typical value, but we can do that. We can do special things with arrays and objects too, right? That's just, we can do this with functions. They have a little bit more functionality, you might say. So, moving on from there, let's jump back to our greeting function. It takes in a name, and then it will console log that name. And we can pass various different things to it. We'll go with Francis again. He's a lecturer in Montreal. That's why he's on my mind right now. We can have a greeting with a number. We could have a greeting with, if we were to store, we can pass a variable, right? And we should just see here console log Francis, console log 37, console log Sam, right? This shouldn't be a surprise to anybody. Francis, 37, Sam, right? So if we can store functions in variables, and we can pass variables to functions, what would be the next logical conclusion from those 2 points? Functions are values. Functions accept values. Functions accept other functions. Let's see what happens. So we need a initial function. Let's just call it our greeting function. And it will accept a name. I don't know why I bothered to erase all that. Here we go. And so we've got our greeting function. And let's have another function. Let's call this one, I don't know, higher order function. A higher order function in JavaScript is a function that accepts other functions as arguments. There's no difference between a regular function and a higher order function, really. We just have this special name for them. We call them higher order functions. And it's going to accept a function. Const equals, if I declare it properly. OK, so now we have two functions. We have a function that takes in a name, some kind of value, and then console logs it. OK, let's use some string interpolation so we get some friendlier stuff in here. OK, so let's say that we have our new function. We've called it higher order func. We can call it whatever we want. It's our function. And it's a function that accepts a function. Cool, right? So if I'm inside of here and I want to make reference to the name variable that got passed in, all I have to do, again, unfortunately named, is say its name, right? If I want to get its value, whatever was passed in, I can just say its name. Same as we were doing here, anything that we were doing in here. But if I want to invoke a function, so I've got this, I could console log this. I could set it equal to another function, to another variable, right? I can pass this around. This is just a value, right? But I can do something else to it. I can invoke it. What is this code going to do? Console log hello Sam. Does everybody agree with that? Let's find out. Clear. Node. Callbacks. Hello Sam. We passed in, because it's just a value, we passed in greeting. Inside of the function, we stored it as func. We could store it as whatever we want, like we said earlier. These are our variables. We control them. So greeting gets passed in as func. And then when we execute func here, this is the equivalent to doing right? And then, unsurprisingly, we got hello Sam. Victoria's fine. Any raised eyebrows? Any questions about this? Yeah, absolutely. OK, so all we're doing up here is the same as we were doing up here. This creates things in memory for us, right? This sets aside these buckets, but it doesn't actually do anything. Like if we ran a file that just had these 3 lines, nothing would output, right? Because we've just set aside these things in memory, and then we didn't do anything with them, and then the application closed. So if I did that, absolutely no response. So all we're doing is creating 2 buckets in memory, one called greeting and one called higher order functions, func. And the values that we're putting into them are functions. They could be anything, but in this case, they're just functions. Okay? So we declared one, and it doesn't matter what order we do this in. It doesn't even matter if the function is in this file or not. We could import it from another file. We could bring it in from somewhere else. The order of these doesn't matter as long as they are both declared before we try to you do something with them. Just like any other value. You wouldn't do like console log name and then set up the variable as name, right? You would do that in a different order, presumably, hopefully, right? So we'll go back. So we set them up into memory before we try to invoke them. Okay? So good with this part? Yes. Can we invoke, for Victoria, the question was, can we invoke the greeting function directly as a parameter? So in other words, do this? Or do you mean like that? Is that what you mean, that we're actually literally passing the function value in? Or did you mean more like this? More like this. Okay. So what is this going to do? This is a very important distinction. Yes. Will it put hello Sam Sam? Let's find out. Func is not a function. Does that make sense? Because what came back from greeting Sam was nothing. We didn't actually return anything. There's no return from here at all. So just like when we did another func and another func, which is a reference to double it, returned that doubled value, right? So this was executed, and then the console log function was executed. So same thing is happening here. This is being executed, and it would write hello Sam to the screen, which it did. But then we tried to pass literally the string hello Sam to our higher order function, which accepts a function. And then we tried to invoke it. So this is the equivalent of trying to do this. And it should come as no surprise to anyone that this does not work, right? So if we invoke the function to be passed in, it needs to return a function. This would have to return some kind of function in order to be executed, in order to be passed along. Otherwise, it's got its greeting here, and then it tries to invoke it up here, and it can't. And in fact, I made a mistake, because that's not what this is. I said that this up here was hello Sam, and in fact it's not. Let me comment this out for a second. What is this going to print to the console? What is this line of code right here going to do? Sorry? It will print out, we've got a guess that's going to print out hello Sam, but that's what greeting does. What's console log going to, sorry? Let's find out. The guess here was it will print out console log hello Sam. Hopefully you have some ideas in Victoria, and clear the console. Undefined. Why did this print? We know why it printed hello Sam, because we know that this executed. But where did the undefined come from? Well, it is actually console logging, and the return value from console log is undefined because there is no return. JavaScript has this idea of implicit return, right? Which hopefully you've come across. But every single function in JavaScript has to return something. Something has to tell it this function is done. And the way that we do that is we return control. If we did something like this, and then we had const name equals Andy, and then we're like blah, blah, blah. Right here, so up here, all we're doing is just setting these things into memory, right? We're not doing anything with them. If we ran this file, it would put stuff into memory, and then it would throw it away during garbage collection. And it would say, that was fun. We didn't actually do anything. Okay? We invoke it, and we do something. So what happens when we invoke greeting Sam? Well, it jumps back up into here, and it goes, OK, we run Sam. Then it returns control back to the main program and continues running again. Okay? JavaScript is synchronous, so it will evaluate this, then it will return. It will evaluate this, which will also return, because that's a function, and then it will continue on down the page. Okay? So since we have this idea that every single function in JavaScript has to return something, that's kind of at odds with the way that we would want to write code, because maybe all this function does is console log. And all console log does is write to standard out, which we call the terminal, or bash, or whatever you prefer. So the JavaScript, the team that developed JavaScript, gave it an implicit return value. If you don't specify any kind of return value in here, if you don't say anything at all, if you're not like returning some value, then it returns undefined. Because every function has to return something, so it just returns undefined. So since greeting Sam, since this function invocation doesn't return anything, we literally just console log the returned value, which was undefined. That's the whole thing about that. Okay? So every single function has a return value. If you don't specify it, it's just going to be undefined. And that's also why if you jump into the REPL and you do something like, you see this. Because the REPL will helpfully show you the return value from the function that was just executed. Okay? Okay. Oh, that's exactly what I didn't want to do. There we go. Okay. Hello, Sam, and undefined. Great. Okay. Any other questions about passing functions to other functions? Yes. Mm-hmm. Oh, so the question for Victoria is, on line 2, we're invoking whatever the function was that was passed in. Oh, but why do we say Sam twice? Because that was actually an error there. So inside of here, func has the value greeting, right? So if we want to, and greeting takes an argument. It takes the argument, we called it name, but it takes in some kind of string and then uses template literal to concatenate it together, right? So if we want to properly invoke it, we have to pass something to it. So we're saying, call that function that's holding the greeting and pass it the value Sam. We could pass it the value Max. When we're invoking the higher order function? No, we just need to give the higher order, all the higher order function is expecting is a function of some kind. Oh, because I have this here twice, or because down here, during the broken example, yeah, that we're, sorry about that. Okay. Any other questions about this? Yes. That's right. So in here, we're just passing this parameter. This can be whatever we want. It could be that we're doing, some other logic in here as well. We're establishing some kind of value. Maybe we're iterating over an array and we're passing each one to the function. Maybe we have an array of names. And so what we can do, if we want to iterate through an array, what are our options? For each. For each sounds good. Does everybody like for each? For each was an excellent choice because of so usually if you're iterating through, by the way, arrays should always be pluralized because they are a collection of things. Okay? Just a little side note. So then it makes it really easy if you want to iterate over them. Let's say you wanted to use a for of loop. You can say for const name of names, for const user of users, for const number of numbers. It makes it really simple to iterate over them. So we've got names.forEach. Every time through this function, we're going to get the name, and we're going to call func on name. What's this going to do? Yes, it's going to say hello to each name. Hello Andy, hello Max, hello Sam. We are iterating through this array. It has 3 elements in it, 0, 1, and 2. We're calling for each. And then we're just passing that name, whatever it was, to this function that got passed in. What if we did? So bear in mind that we can pass anything to it that's a valid function. What is this going to do now? Inside of here, func equals console log. It's just going to console log all the names. Andy, Max, and Sam. So that's it. We can pass in any valid function, whether that function accepts parameters or not. Oh, double it equals function. I just want to do this with something that doesn't, and we're just going to return 4. Let's call this does nothing. And we're going to execute this with does nothing. So we now have a function in memory. I'll minimize that so we can see it a little better. We now have a function in memory called does nothing that just returns 4. And we're going to pass that into here. So inside of here is now does nothing. So what is this going to do for us? If I call higher order function and I pass it, does nothing. Nothing. That was an excellent guess. Nothing. Because we're not actually doing anything with this return value. This could, in fact, be completely empty, and we would get the same thing. We run this, and nothing happens. JavaScript doesn't complain, because as we saw before, you can pass arguments to a function that doesn't accept arguments, and you can not pass arguments to a function that does accept arguments. Right? Did I lose anybody there? Okay, so believe it or not, does this sentence make sense now? A callback is a function that gets passed to another function to be executed by that function. Let's get rid of does nothing, and we'll jump back to our original greeting example so that we can just clean this up a bit. There we go. A callback is a function that gets passed to another function to be executed by that function. We have 2 functions on this page. I'll make this multiple choice for you. Which one's the callback? Greeting. Did that agree with everybody? Victoria? Greeting. Greeting is the callback function. It's a function that we're passing, to another function. We're passing it in as a value. We're not invoking it. I want to stress that. We're saying its name so that we get its value back. Then we pass its value inside the function, and inside of this function, it is invoked. Cool? That is, if you can wrap your mind around that, that is exactly what a callback is. That's all it is. It's just a function that we give to another function, and that function invokes it. And that's it. And you will see this paradigm all over JavaScript. This is why it's so important. This is why it's a week 1 fundamental that you're picking up, because you will use callbacks pretty much every single day for the rest of this curriculum. And many, many times while you're on the job. This is because we can encapsulate, this is what we're here. We're wrapping up functionality as we talked at the beginning. What does a function do? It encapsulates, it abstracts away complexity into a little package that we can run over and over and over and over again, right? So do we have an example on this page of a function that accepts a callback? We actually have 2 examples on this page of a function that accepts a callback. We have the one that I wrote, that we wrote together, but there's another one on this page that's doing the same thing. For each. For each is taking in a callback. And to illustrate that, I'm going to call this callback equals what's this going to do? We went from having it declared inline to I pulled it out, stored it in a variable, and then we're going to invoke it. What's this going to do? Exactly the same thing. This, let me see if I can put them both on the same line. Or at least side by side. This is equivalent to this. What's the difference there? It's just as equivalent as we can agree that these are both going to console log the string Andy to the terminal, right? What's the difference between these two? Output-wise, there's absolutely no difference, right? All we did was take the time to put this value into a variable and then call it from there. What's the difference between this one and this one? Output-wise, as we saw, absolutely nothing, right? Because just like we can just pass in the actual value here rather than having to store it first, why do we need to store our functions first? Why can't we just put them in line? Yes, that would be the only reason for Victoria to access them in the future. That is the only reason, well, one of the most important reasons to store it in a variable. If you're not going to use it again, and it doesn't aid in the readability of your code, then why would you bother? Because what did I have to do here? I had to come up with a name for this thing. That's hard. Hang on a second. See, Google knew naming things is hard. Yeah, see? There are only 2 hard things in computer science: cache invalidation and naming things. Okay? That's it. There's 2 hard things. And you always want to stress the most important things at the end, so presumably cache invalidation is easier than naming things, right? You always want to end on a high note. So why would I go through all of the effort of coming up with some kind of descriptive name for this function? Why wouldn't I just put it in line? Right? Okay, so what is, remember how we talked about we say a variable's name and we get its value, right? Okay, so what is the name of this function? Callback. Cool. Like I said, there's no trick questions. What is the name of this function? The name of this method is for each. Sorry, I was highlighting the function that we passed inside, the equivalent to this. What is the name of this function? It is anonymous, so it doesn't have a name. What does anonymous mean? It means no name. We didn't have to bother going through the hard thing of actually naming it. We just passed it in line. We did the exact same thing I did here. Instead of storing it in a variable, you just pass it right in, right? Instead of storing it inside of a variable, we just passed it in. And we call this an anonymous function because it has no name. It doesn't have a name. Nothing. It's just passed in there. Seemingly complex, but not complex at all. What's an anonymous function? Function that has no name. What's an anonymous person? Person with no name, right? So if we don't need to use this value again in the future, we might as well just pass it in line. And you'll see this so many times, so much more often than actually naming your thing. Just like for each, you'll very rarely see it where you name a function and then pass it to for each. You'll usually just see it right in line, okay? We do this all over the place. So there's another type of function that we haven't really touched on yet, but hopefully you've done some reading on, and that is arrow functions. Devs love arrow functions. Like I said, we don't like naming things, whatever cache invalidation is, and typing things out. What was one of the first things I taught you? Tab autocomplete, right? We don't like typing things out. So what is the syntax for an arrow function? Well, we drop the function word, right? So if we're going to convert this, hello from arrow function. Cool. Do we have any weird console logs that we can get rid of? Okay. So we have this. This is how we declare a normal function, right? So all we do with an arrow function is we get rid of that word, and we put an arrow in between the arguments and the body. And that's it. That's what we call an arrow function. And if we were going to accept parameters, we would accept parameters. Right? So all this is, the difference is regular function, arrow function. And you'll hear some of us refer to this as a fat arrow function, because in other programming languages, this would be a fat arrow, and this is a skinny arrow. But we don't have the same concept in JavaScript, but we like to say stuff like that. So you'll hear either arrow function or fat arrow function. Okay? So the advantage to this is we didn't have to write this word. That's 8 characters that we didn't need. And I get to use like a greater than sign and an equal sign and make like a little pointer. So if we extrapolate from that, our arrow function, how can we refactor our for each here? Well, step 1, delete the function keyword. Step 2, put in an arrow. And if we run this, hello Andy, hello Max, hello Sam. So there are various different reasons for arrow functions to have been incorporated into the language. They were part of ES6, which was ECMAScript 2016 or newer. And so they didn't exist. If you went back 10 years and said, I want to use an arrow function, people would have no idea what you're talking about. Like I said, languages evolve, things change, stuff is different. The reason why we use the arrow functions is because it's just less typing. These are, for most intents and purposes, the only reason why this is different is if you use this it becomes different. But if you're not making reference to this inside of the function, and if you don't even know really what this is at this point, that's totally fine. Anywhere you see a function, you can insert an arrow function instead. And we simply do it because syntactically, it's shorter to type out. They're super quick to just get used to just going open and closing, arrow, curly braces, there's my function. To see them side by side, these two lines of code are equivalent. They both create anonymous functions. You can just see that this one is much shorter to type than this one. Okay? Programmers are lazy by design. It's just we are. So, cool. So that's arrow functions. Another thing that kind of trips people up. But that's it. The arrow just takes the place of the word function. Yes? Sorry? Oh, you can get rid, sorry, for Victoria, the question is can we do this? And you can. That is valid JavaScript. And in fact, you can do this as well. That is also valid JavaScript. If you just have a single thing that's happening, you don't have to put the curly braces in. However, I would highly recommend that you always do that. What did I forget? Did I not step back far enough? There we go. So why would I recommend this over that simple? I said that devs are lazy. Why would I want to type these parens every time? Why would I want to put in these curly braces every time? Sorry? Readability, it definitely helps, especially for new programmers. There is this idea that we want to write the most clever code possible, that we want to devastate people with how smart we are, right? We want people to look at our code and be like, oh, I will never compare to this person. I don't even understand what this code is doing. No, that's not our goal at all. Why do we write in JavaScript? Why do we use a human readable language to program in? Does my MacBook understand JavaScript? No. My MacBook doesn't understand JavaScript. My MacBook understands binary. If I wanted to write a program for my MacBook to understand, I would write it in binary. I would write machine code. I'd write a low-level language. Why did we abstract all the way up from binary, all the way up to human-readable languages? To communicate. Exactly. We want to write code that other programmers can read. That's why we write in English. That's why we use words like function. And this isn't 01000100, right? We write, what did I just erase there? Okay. We write in English for the most part, or truncated English if we use things like func and stuff like that. But it's for other programmers to read. So when you're working on a dev team and you do something that's absolutely amazing and you're like, look, I shortened this line of code down. It's only 10 characters now. Hang on. Look at this. Readability. If the other people on your team don't understand intuitively what this is doing, then they're going to have to slack you and say, can you explain this code? I don't know what's happening. Yes. So the question for Victoria is, do other countries use different syntax? Or another way is, do they write in a language that's not English? No. There are more than likely other programming languages not written in English, but not in English. Yeah, look at that. Google is on top of it today. Non-English based programming languages. So there's a read. Wow, there's a ton of them. Look at that. But English is, it's the lingua franca of the world, right? For good or for ill. If someone who speaks French wants to speak to someone who speaks Spanish, what language are they going to speak? More than likely English, right? That's what lingua franca means. It means a common tongue. So for good or for ill, English is the common tongue on this planet right now. And programming languages are written in the common tongue. Ruby was invented by a native Japanese speaker who wrote Ruby for two reasons. One, to create the perfect programming language, and two, to learn how to speak English. When he started, he didn't, this is the story that goes along with it, is that he didn't understand English. He wanted to learn English and write a programming language. And Ruby was born. Okay? So hopefully that answered that. So readability, the other thing is, if we jump back to this, let's say something's going wrong with the code. And I want to see, like, something's definitely weird. I want to console log this. And maybe I want to do more stuff. Well, if I had omitted these, I now get errors, right? So the reason why I always include these curly braces is because what if you want to come back? Sure, it's just one line of code right now, but what if you want to come back in the future and add on to this? What if you want to jump into here and add more vars and more, right? It quickly becomes unreadable. It's the same reason why that's perfectly valid JavaScript. If, condition, single line. But we don't write it like that, right? We do this instead. For readability and maintainability, because if we want to get in here and add another line of code, we can with those curly braces. Okay? So I would recommend that even though you can shorten this down and pull these different things out and get rid of this and get rid of that, sometimes being clever is not, it's the same thing that if I was talking to you and I started using gigantic words that you don't understand, that's what's the point in communicating is about I say something and you receive it and you understand it. And when you say something, I receive it and I understand it, right? If I talk over you or beneath you, then we're not lining up. Our communication has broken down. So if I write the most clever code I've ever conceived of and you don't understand it, then what was the point? What if I leave my job and somebody else has to inherit that and they go, I have no idea what this code is doing and I'm afraid to change anything because I don't know what I'm going to break. Write code that's understandable by other devs. This is why we're known as authors. If we look at our GitHub, it says that we are the author of that code. Okay? We're writing a story for other devs to read. We're writing functionality for other devs to use. Okay? All right, 1149. Let's see what we can knock off real quick. Does this sentence make sense now? Callback is a function that gets passed to another function to be executed by that function. Okay? Functions are values. We can call them, we can invoke them, or we can pass them. Remember that when you pass it, down here, you don't invoke it. You just say its name to get its value back, right? Because we already saw the error that comes when you do this. Okay? So that's a big distinction. Callback functions and higher order functions. We know what a callback is now. Higher order is simply a function that accepts another function. What's the difference between that and a regular function? Not much. It accepts a value. That's it. But we call them higher order functions because we like to attach names and labels to things. We talked about anonymous functions. What's an anonymous function? It's a function that has no name, right? So we talked about arrow functions and their common use as callback functions. Because remember what I said, instead of pulling this out and storing it in a variable, we like to inline our function calls so we don't have to come up with a name and actually store it somewhere, and we actually had to write extra code here. We just pass it in line, and you can see that arrow functions shorten that even further. So they are extremely popular for callback functions. You'll see them all over the place. Okay? And we even spoke a little bit about scope when we did that console log name example. And we didn't actually have, I think I've gotten rid of the example, but where it wasn't declared locally, so it went up the scope chain to look and see if there was a name variable defined anywhere else, right? So we have one last thing that we can do. We have 9 minutes left. Let's implement our own version of for each super quick. Does that sound like something that we can tackle? That was for Victoria, that was a resounding yes, and they all jumped to their feet and clapped. Okay. Perfect. Okay, so what does for each do? What did we do in the callback thing? That's exactly right. Any for loop, what are we doing? We're looping, right? We want to looping through each element. Okay, so I know that we need a function called for each, right? We won't be able to do array.forEach like we can. We're going to pretend that that was never created for us. We need to create our own for each for looping over something. So const for each equals a function. And what is this function going to accept? What does for each loop over? It loops over an array. Exactly. So we'll just call that R. You tend to write functions, or you want to write functions, as generically as possible. We don't care if this is an array of names. We don't care if it's an array of ages. We don't care if it's an array of objects. We're just going to iterate over it, right? Our function doesn't care. Just like array.forEach, names, it didn't care what was in names. It doesn't care at all. You want to write your functions as generically as possible and stay away from specifics, because specifics bind your code to a specific situation. If this was for each name, that would be awkward, because what if you want to iterate over something that's not a name? So we write these as generically as possible. Okay, so we accept an array as an argument. What else does for each accept? A callback, exactly. So what are we going to call our callback? CB. Let's call it CB. Okay, so we don't have for each available to us. We need to loop over this array. What are we going to do? What else do we have available to us? You have every other part of JavaScript except for each. Just a regular for loop. What do we like? Do we like a for of, a for in, C-style for loop? What do we like? C-style for loop, okay. Let I equal 0, I is less than r.length, I plus plus. Okay, so it should be evident to everybody that we can grab the ith element of the array, right? Using square bracket syntax. We're iterating over it. Let's take an iterative approach here. What is our array going to be? What are we going to iterate over? Sorry? Dogs. Perfect. So dog breeds or dog names? Names? Breeds? Breeds? Names? Okay. We need a dog name. Does anybody have a dog? Henry. I like Henry with a Y or an I. Perfect. Any other dog names? Stormy. Okay. Let's grab another dog name. Anything? Fido. Sorry? Dallas. I like that. Dallas. One that came up during a lecture that I had with Nima was one of my cohort mates yelled out, DOG! And to which Nima replied, DOG? Because it totally went over his head that they just spelt the word dog. So we're going to throw in DOG for Nima. Okay, so let's execute our function, and we'll pass it our dogs array. We're not going to worry about the callback just for this second. We just want to make sure that we are successfully iterating over the array and console logging each element, right? Clear the console, node, for each. Henry, Stormy, Fido, Dallas, DOG. Okay? So we know that we can access the ith element of the array with our square bracket I, whatever our iterator is, right? Okay, so where does the callback fit into this? What did for each's callback do? It might be easier to reason about it here. The callback was a function that accepted a parameter, and then it did something with that parameter, right? So if we look at this, we accept a parameter, and then we do something with it, okay? So we're going to assume, but from inside of higher order function, what did we do? We just called func with whatever that parameter was, right? So can the same principle hold? Can we just call callback with whatever the ith element is? Yes? No? Yeah? We're almost there. It's almost lunchtime. Okay, did I lose anybody? That we're doing the exact same thing. Our higher order function accepts a callback, another function, and then we invoke it inside of that function. So our for each accepts a callback, and then it's going to run it for every single element inside the array that was passed in, right? So we need to write this callback function when we invoke it, right? Because if we try to run this file now, CB is not a function because we didn't define it. So what's its default value? Undefined. So right now it's trying to go undefined at Henry, and we're getting this error. CB is not a function, right? We need to give this side some kind of value. We need to make it something for us. So why don't we use an anonymous arrow function? We can just do it right in line. Okay? So this is where we can get specific, because we are outside of our for each. Our for each was written as anonymously as possible. It should be evident that it can accept anything that's an array and anything that's a function. And it will just iterate over it and call that function for every single element in it, which is what for each does, right? It loops through an array, and then it executes a function, which we pass to it. It executes this callback function for every single element in the array. So our callback function is going to accept a dog, and then what are we going to do to the dog? We might as well console log it, right? Because that's always fun. And we've just written our own version of for each. The exact same thing would be arrived at with dogs.forEach. And we're going to pass in an anonymous function that console logs I'll throw in a console log here just to break that up a bit. Clear? It seems like we did pretty well, right? Our for each does the exact same thing that the regular for each does, that this one does, except we weren't able to build it into the language. So instead of it being a method on the dogs array that we're using, we actually just pass dogs in as an argument. But other than that, yes. Oh, what if you wanted to get the index of the dog? Perfect. So let's write a function. Let's just comment this out for now. We want to be able to write a function where we get the index as well, right? So we're saying, and its index is index. So right now, if we run this, we see, and its index is undefined. Okay? So if we want the index, if we want to shape our callbacks that we get the index as well, we need to pass the index to the function when we invoke it. So what is our index inside of here? I. And now we'll see, clear? My dog is named Henry, and its index is 0. My dog is named Stormy, and its index is 1. You can make your functions that accept callbacks as complicated as you want, or as simple as you want. You're writing the code that's going to run this function. And you wouldn't do it the way that I did it, which is where I defined my callback first. You would look up, if you're going to look up something that takes a callback, let's say look at the for each in JavaScript. Let's see if we can find the, there we go. And then you would define for other developers what you want their callbacks to look like, how you want them to be shaped. This callback that gets passed to for each should accept the current value, which is what we do with our dog. We accept the current value. Then optionally, that's what the square brackets mean inside of this type of thing. We can optionally pass in an index and optionally pass in the array. And then also some other arguments that we can see down here. So current value is the current element being processed in the array, which for ours is r at I. For the for each, it was just dog. It was whatever we wanted to call it. So you are going to write abstractions like we just did. We wrapped up all of this functionality so that all that another dev has to do is they just go, oh, okay, you want to take in an array and some kind of callback function. Awesome. I'm going to call your function. I'm going to pass an array, and I'm going to pass a callback function. And we're using inline so that we don't have to set it equal to some variable outside. Okay? Does that make sense? How are we doing? 12:02, we're 2 minutes past. So we managed to implement our own for each as well. Any questions? Does everybody feel confident in what a callback is? At least to say, yes, this is a callback. Maybe you're not so good on the syntax. Maybe you're going to have to look at the notes or work your way through Compass today. But could you tell someone in English what a callback is? If you were in a job interview and somebody said, what is a callback? What would you say? That's it. Exactly. Should get it tattooed on my chest. Perfect. Any questions? Anything from Victoria? Anything at all? Are we good? Cool. Thank you very much. If you have any questions, I'm available on Slack. I've got to go to my regular gig after this. But if you think of anything, hit me up. Otherwise, I'll send the notes out shortly. Thank you for your time. Thank you. Thank you, Victoria.